8 preparation series. In this series of videos, we are going to talk about engineering mathematics. Okay, so engineering mathematics is a very broad area. This is the first thing we are start with linear algebra series. In the linear algebra series, we first start with matrix. That is algebra of matrix we are going to start. So before algebra matrix, I want to emphasize what is the matrix and how to we are adding to matrix. That is matrix operation we are going to see now first. First we start with what is the matrix. First we say definition. A matrix A is a rectangular array of scalars usually presented in the following form. These are the matrices. A is, I write it as A11, A12, like that, A1n, A21, A22, and so on, A2n, AM1, AM1, AM2, AMN, this is the matrix usually represented in this form. So this guy, this is the first column. We called as a first row. This is second row. This is mth row. This one is first column. This is second column. This is nth column. Okay. So this is the matrix. So okay. So each element, suppose this is A22 means the subscript means the second row, second column. This meaning is second row nth column element. Suppose if you have that any arbitrary element, we can denote it as Aij. That meaning is this is the element of a matrix the position is ith row and jth column. That way only we define. Some people denoted the matrix is simply A equal to the square bracket of Aij and they mention what is the how many rows and how many columns. Shortly, we don't like that. Okay. This is the usually we define as a matrix. Now first we see what is the size of the matrix and how we do it. A matrix with m rows and n columns is called m by n matrix. Okay, suppose I will give some one example, that is I say some matrix A, that is 1, -4, 5, 0, 3 and -2. Okay, this is how many rows will be there? 2 rows will be there, correct? This is the first row, this is first row, this is second row, correct? This is the first column, this is second column, this is third column. So this is 2 by 3 matrix. So 2 by 3 matrix. So the first row is, suppose with the row is, this is the first row, that is first row is first row of A, is 1, -4, 5. This is my first row, correct? What is the second row? Second row of A is 0, 3, -2. And what is the first column? First column of A is 1, 0. Second column is of A is -4, 3. You can find what is the third column of the matrix A. Please post in the comment box. So you can write this way, or you can write it in the row way also, like that also. 1, -4, 5. And this is also you can write it as 0, 3, -2. And similarly the column matrix you can write as 1, 0. This one is -4 and 3. So this is the example of the matrix 2 by 3 matrix. Next, so I am telling now here m by n matrix. The pair of numbers, second point I want to say, the pair of numbers m and n is called the size of the matrix. So this is, what is the size of the matrix is 2 by 3, that is 2, 3. It is the size of the matrix. Next we are going to say how to say two matrices are equal. That is my third point. Third point is, first we say what is the matrix and what is their order, what is the size, second is what is size. Third is we are saying that two matrices A and B A and B are equal. Written A equal to B when we say if, when we say means if they have the same size and if corresponding elements are equal. So what is it when we say two matrices are equal? They have the same size and their corresponding elements are equal. So now we see one example. Suppose I say I take the A is a matrix, that is x plus y, and second row first column is x minus y. Third row, first row second column is 2s plus t and s minus t. That is my second row. This is the matrix A. The another matrix is B is 3, 7, 1, 5. So what can I do? I want to say, suppose I say that if A equal to B, find x, y, s and t. How I can find? Because two matrices are equal means they have the same size. Yes, the matrix A is 2 by 2 matrix. Matrix B also 2 by 2 matrix. So these are the same size. What is to say? If the corresponding elements are equal, that meaning is, what is the meaning? Is x plus y equal to 3, x minus y equal to 1. Similarly, second row, first row, second column is 2s plus t equal to 7, and the second row, second column is s minus t equal to 5. So here two equation, this is the two equation, two column, so two equation, two unknown. Here also two equation, two unknown. We can find the solution. If you are finding, if you are add together, you will get 2x equal to 4, that is x equal to 2. Then y equal to 1. If you are applying that one, you will get that y equal to 1. Similarly here, if you are add together this equation, 3s equal to 12, this implies s equal to 4. Once you apply s equal to 4, t equal to minus 1, you will get the answer. Okay. So this is the most way. So whenever two matrices are equal means, we can say they have the same number of size, that is 2 by 2 or 3 by 2 or 3 by, need not be a rectangle square matrix. Okay, it may be different. So m by n matrix also fine. Suppose A is m by n and B also m by n must be there. Different size matrix means directly we can say these two matrices are not equal directly. This is my third point. What is the fourth point? Fourth point is I want to say there are so many subdivisions. The fourth point, A first. A matrix with only one row is called row matrix, or so mostly everyone prefer not row matrix or row vector. Everyone prefer row vector only. Okay. So a matrix has only one row. Then that type of matrix we call as a row matrix. Particularly we call as a row vector. That is, the example is I take as A equal to 1, 3, 7, 8. So this is how many rows? 1 row, 4 column. So it has only 1 row. So then we call this a row vector or row matrix. Second is similarly a matrix with only one column we call it as a column vector. A matrix with only one column is called a column matrix or column vector. Here also people are mostly used the term is column vector only, not column matrix. So a matrix has only one column. Suppose I take the B matrix as 4, 3, 2, 1. Okay. This is 4 rows, 1 column. Such a type of matrix we call as a column matrix or column vector. A matrix who all the elements are 0, that is called, so we say a matrix whose entries are all 0. Are all 0, we call it as a 0 matrix. Zero matrix. And it is denoted by simply a 0. They give the simply, sometimes they give the order. Suppose it's a m by n matrix means they give 0 m by n. Okay. Suppose I take 0, the mean example I am saying 0 order 2 by 3 means, so how many rows I want to say? I say 2 rows will be there, that is first row, second row. How many columns? 3 columns. So 3 columns, 3 zeros. So this is the example of 0 matrix. Next, so this video purpose is operation of the matrix. So operation of matrix. There is a 2 operation will be there. First one is matrix addition. Second one is scalar multiplication. So what is the matrix addition? We say let A and B be two matrices with same size. So here this is the important trick, both must be the same size. Say m by n. Okay, so that is, I take the A is a matrix of the same size. Okay, A equal to, suppose m row n column. So that is A 1 1. This is the second entry is A 1 2 and so on. A 1 n because n column. Similarly, A 2 1, A 2 2 and so on. A 2 n. So this is A m1, A m2, A mn. This is the matrix I have taken as A, and B is the another matrix, the same size m by n. So m rows, n column, the same matrix B11, B12 and so on, B1n, B21, B22 and so on, B2n, BM1, BM2, Bmn. This is the matrix B. Suppose I say that to matrix, this is the m by n matrix. Now I want to say A plus B. This is the sum of the matrix A plus B defined as nothing but I say A11 plus B11. That is corresponding elements only I am adding. Okay, A12 plus B12 and so on. A1n plus B1n. Similarly, A21 plus B21. A22 plus B22. Similarly, A2n plus B2n. So nothing but I am adding the corresponding entries. Okay, this is only possible both have the same size, otherwise it is impossible. This is we define as a scalar vector matrix addition. We see one example. Let's say A equal to, example, A equal to 1 minus 2 3 0 4 5. A is a 2 by 3 matrix. Now the matrix B I taken as 4 6 8, 1 minus 3 minus 7. Now A plus B, sum of the matrix means, what is the definition say? I want to say at the corresponding elements. Suppose here will be the first element will be the this element and here first element. So I write it as 1 plus 4. Now we go to the, this is the first row, first element over. First row, second column element is minus 2 and 6. So we get minus 2 plus 6. This is the third one. I will take it as 3 and 8. So what will come? 3 plus 8. What about this element and this element? I want to add mean 0 plus 1. This is 4. This is minus 3. If you are adding means you will get it as 4 minus 3. Then next one is I will take an as 5 minus 7. So 5 plus minus 7 is, I say 5 minus 7. This is the resultant matrix. If I know how I can add the two numbers, the same idea I will apply. 5 minus 4, 11, 1, 1 minus 2. This is the sum of the two matrices. Okay. This is the matrix addition. Second operation is scalar multiplication. What is the scalar multiplication? Means the product of the matrix of the matrix A by a scalar some k written by Ka is the, this is the matrix obtained by multiplying each element of A by K. That is, suppose I take A is the matrix is this one. Okay. Suppose I have the matrix K times A. This A matrix is, this one is the my A matrix. So how I can write is Ka means I want to multiply each entries by K, the scalar K. Ka11, Ka12 and so on, Ka1n. Similarly here K21, K22, Ka2n. Similarly you want to take Ka_m1, Ka_m2, Ka_mn. So I simply multiply the each entries by that scalar A. Suppose I want to find 3A. Suppose I want to find, suppose the matrix A, this is the A matrix. Now I want to find 3A. 3 is a scalar, correct? What I want to get 3A means 3 times 1, 3 times second entry is minus 2, third entry, that is first row, third column entry is minus 3, so 3 times minus 3, so 3 times 0, 4 times, 3 times 4, 3 times 5. So this is my 3A, the scalar multiplication of the matrix A. The scalar is here 3. Suppose I have the matrix here 2A and B. Now suppose I evaluate 2A minus 3B. Okay, that is 2 times scalar multiplication of A minus 3 times B. Okay, so I will just evaluate what is 2A. First I want to find what is the first step. I want to find what is the 2A. The 2A I directly write because the same process. 2 times I multiply the given matrix. So 2 times 1 is 2, 2 times minus 2 is minus 4, 2 times 3 is 6, 2 times 0 is 0, 2 times 4 is 8, 2 times 5 is 10. Similarly, I want to find what is the 3B. That is the matrix B multiplied by each entries by 3. That is 3 times 4 is 12, 3 times 6 is 18, 3 times 8 is 24, and 1 times 3 is 3, minus 3 times minus 3 is 9, minus 9, minus 21. Last entries, correct? Now I want to subtract. How I don't know how to subtract, correct? This is the very tricky point. Now I want to multiply 3 minus 1 times 3 times B. So this is the matrix B. So I multiply each entry by minus 1. So minus 12, minus 18, minus 24, minus 3, plus 9, plus 21. This is minus 3B. Okay, this is equal to minus 3B. Otherwise you multiply, instead of 3B you multiply minus 3 by B, because minus 3 also one scalar. So you can find 2A minus 3B. So it's nothing but you simply add these two entries. That is, you will get that minus 10, minus 22, because minus 4 minus 18 is minus 2. Here you will get the minus 18. Here you will get minus 3. Here you will get it as 17. Here you will get it as 31. This is the matrix of 2A minus 3B. So this is matrix we called as a linear. This matrix, suppose I assume this matrix is C. Okay, the C matrix is called, that is resulting matrix is called a linear combination of A and B. Okay, so I am going to stop now here. This is the gate series. Okay, if you have any doubts, please post in the comments section. Okay, so this video we are defining what is the matrix, then we define what is the order of the size of the matrix, and what is the row of the matrix, what is the column of the matrix, and how to say two matrices are equal. Then finally, what is the row vector and the column vector. Zero matrix also I define. Then we see the operation of matrix. There is a two operation. First one is matrix addition, second one is matrix scalar multiplication. Then finally we end with the linear combination of the matrix. I hope you enjoy this video. Thank you for watching.